All right, we'll go ahead and get started. Good morning, everyone. My name is Amanda Sheffield. I am the Regional Drought Information Coordinator for NIDIS. I'm located at Scripps Institution of Oceanography. Welcome to today's May California-Nevada Drought Early Warning System Drought and Climate Outlook webinar. Thank you to those that have joined us previously and those who may be joining us for the first time. As many recall, these webinar series are designed to provide California, Nevada with timely information on current drought status and associated impacts, as well as a preview of developing climatic events, or today, for example, wildfire impacts and potential for that for the season, as well as related research and the update. This webinar is co-hosted with CNAP, the California Nevada Applications Program, who is a NOAA RESA team. Before we get started, I'll just note that this webinar is being recorded, and the recording along with a 2-page summary will be available later this week on drought.gov and also on the NIDIS YouTube channel. Before we go and get to our great speakers, I thought I'd just mention a little bit about NIDIS. Our mission is to improve the nation's capacity to proactively manage drought. We work basically to improve our understanding of how and why drought occurs, providing resources and information, as well as any information that can help us better prepare for, mitigate, or respond to the effects of drought. And we do this, we work to achieve this goal through the foundation of a national drought early warning system, and through regional drought early warning systems. As you see here in California, Nevada is one of these regional DEWS or drought early warning systems. Each DEWS has different components and activities that we try to work on, from observation and monitoring to predictions and forecasting, planning and preparedness, interdisciplinary research and applications, and communication outreach, such as webinars like these. Overall goal is just to have readily available information that's easily understandable and usable for the public and also for decision makers. And so today we've got one more slide before that. One thing, since today is fire themed, I just wanted to mention that NIDIS has worked on several of these core topics across the nation and have impacts everywhere, and one of them being wildland fire. And so with partners at the Western Regional Climate Center at the Desert Research Institute, we have released a drought and wildfire nexus strategic plan, which lists ongoing activities, but also activities that we can work forward towards improving, getting better drought and wildland fire information together and proactively managed for the risk. And so with that, we'll get started onto the webinar. We have a great set of 3 speakers today. The first one will be Dr. Dan Cayan. He will give the Drought and Climate Update and Outlook. He is one of the lead investigators for CNAP, the NOAA RESA team, and is located here at Scripps Institution of Oceanography at UC San Diego. Following after that will be a presentation from the National Interagency Fire Center on the Wildland Fire Potential Outlook, and then also by Dr. Dan McEvoy from the Western Regional Climate Center, also a member of CNAP, on his recent work about drought indices and wildfire for California and Nevada. And then with that, I will pass control over to Dan Cayan for the first presentation. Dan, are you ready?
I am ready, Amanda.
Here you go.
Well, that's my last slide. So let me just do a little gymnastics here and get us to the right location. Can you hear me?
Yes.
Okay, we should be seeing my opening slide here.
Yep, you're good to go.
All right, hi everybody. This is Dan Cayan, and thanks Amanda. Thanks Dan McEvoy and Julie Kalansky for input to this slide, to this presentation. I'm gonna cover the springtime short period climate conditions, but there's obvious linkages to our winter time here in California and Nevada, so we'll also be looking at that. This scene is kind of emblematic of what we've seen this year, a very well-distributed precipitation season. We're seeing in this landscape a tremendous wildflower bloom, which was conditioned by the early and later rains. This is in Walker Canyon up in the Lake Elsinore area in Southern California. Okay, good. Here's the current drought monitor for the United States, which is pretty bland, and of course that's a good thing. In the far west, there's only a minor D0 area in the coastal Southern California region, largely I think because of water storage situations there that have built up. Of course, the Pacific Northwest has had some dry conditions this winter, so there's more acute dryness in the far Pacific Northwest. There was a marked change this year compared to last year at this time, which is shown there at the right-hand inset, wherein the Southwest was really pocketed with moderate to extreme drought, and to large degree that has disappeared. There's still a bit of dryness just south of the Four Corners area in the current situation, but certainly much milder than last year. Precipitation over the last couple of months, actually the last 3 months, shown on the left-hand slide, indicates that over much of the Southwest, including California and Nevada, precipitation has been relatively wet and in excess, in some cases, of over 150% of normal. There is a slice in far Southern California that did not achieve that degree of wetness, and here is actually registering drier. But I would point out that this map leaves out the last few days of May, and we've actually had some precipitation down here during that period. So conditions are probably a little better. The right-hand inset shows the entire water year to date beginning in October 1 and indicates the relatively wealthy precipitation that's occurred over much of the southwestern region. You can see that there's a piece of New Mexico that's still relatively lean as far as precipitation, but most of the rest of the region, including much of the west, is on the above 100% or more of long-term averages. Again, there's a little triangle in the Pacific Northwest where conditions are relatively dry. There's a few patches of drier conditions, but nothing serious over the entire season. Okay, I'm trying to advance to my next slide, and it's thwarting me. There we go. This is a temperature departure. And again, on the left-hand side, we're showing the period beginning, in this case, the very end of February through near present, showing that temperatures have been hovering over this 3-month period near normal. There's areas of coastal California that are in the 0 to 2 degrees Celsius Fahrenheit above normal. Much of the region is a little cooler than normal, indicated by the green shading, including the Sierras and pockets of Nevada, much of Arizona, New Mexico, Utah, in that range. The season as a whole, which is shown on the right-hand side, is pretty much a similar map, and again, the temperatures seasonally pretty close to average. This next slide actually shows a different. The previous one was a map that was assembled from in situ surface monitoring stations by the Western Regional Climate Center. This rendition on the left-hand side, which goes back to November, is a picture from the North American Regional Reanalysis, largely showing a very similar picture where much of the region is in near normal. There's actually quite a large negative departure that occupies the interior Northwest. But again, what we're seeing here is a water year that has been close to climatological normal, which in terms of what we've seen relatively recently over the last few years, whoops, I lost my screen, is somewhat unusual. We've gone through a 6-year period where temperatures have really been on the warm side for the cool half year, which is shown at the top on the right-hand side. And just as kind of a teaser for what we may anticipate during the latter part of the summer, I thought it's interesting to see the context of May through October temperatures shown there at the bottom, which have been similarly warm over the last decade or so by and large. Those data from the California Climate Tracker. Another view of precipitation in California. So this is the entire state. This is a product that Dave Pierce here at Scripps put together, showing the accumulation of precipitation statewide going back to October, and indicating how the water year here really took off during parts of the month of January, and then particularly in February and March, we saw large increases in the delivery of precipitation to the state, so that relative to long-term averages indicated there by the dotted blue line, we are sitting at something like 125% of average for the statewide conditions here in California presently. Snowpack in the Sierra Nevada, which in this case I've selected the Central Sierra snowpack as a representative picture, was bountiful. Normal conditions, long-term averages indicated by the dashed black line there. This year indicated by the yellow trace. And we can see that, again, beginning in January, particularly then through February and March, we had quite a lot of snow deposited in the Sierra Nevada range, climbing up to something in the neighborhood of 70% of average. We've already started melting quite a bit of that heavy snowpack, which diminished on into the second week of May, when there was a relatively warm spell. You can see in a recent redepositing of snow there at the very end of this period, which is indicative of the recent storms we've had. The right-hand slide shows the Upper Colorado, which also did pretty well, not proportionately as the Sierras, but still significantly above long-term averages, and that's led to relatively high anticipated discharge into the Colorado system this year to come, as that snow melts off. This slide, which is the Merced River, which drains the sort of south central portion of the Sierra Nevada. The larger hydrograph here indicates the melting of snow that's occurred. You can see actually the pulses of melt as we've gone through warm spells. You can also see the diurnal flavor of melt that occurs on a daily basis. That melting and subsequent discharge into the Merced was, at least so far, reached an apex in late April and the earlier part of May, and has declined recently, I think largely because temperatures and cloudiness has taken over. I believe there's probably going to be another pulse of heavier snowmelt as temperatures warm, perhaps later this week. Also on the right-hand side here is, as an inset, shows discharge on the same Merced River Happy Isles gauge going back to 2010, and you can kind of put the present year into the context of what's happened over this longer period. A heavier runoff season than last year, but probably not as heavy as the 2017 year, which was really one of the largest in the historical record in this area. Lake Tahoe levels, which are shown here, thanks Julie for providing this, are well above the natural rim of the lake, which of course that's getting quite low, but we are seeing the level of Lake Tahoe benefiting from the heavy precipitation and snowmelt that's occurred here in recent weeks. So conditions there pretty well. From the River Forecast Center in the Sacramento region, they are showing the projected stream discharge over not only California but parts of Nevada region, and by and large these seasonal discharges are very healthy, in many cases exceeding 150% of long-term averages indicated by the dark blue colors. Just by way of comparison, I pulled this slide from the talk that Dan McEvoy gave at just about the same time last year, and you can see the marked contrast with discharges that were anticipated in 2018 compared to the present. Actually, now that I notice it, I think Dan's were observed discharges, where these are actually forecasted on the left, but I think the message is still the same. Reservoir conditions over the state of California are in good shape. In many cases, just below flood reservation thresholds, and as is shown in this chart, a fair bit of snowmelt coming in and also anticipated to occur through the July period. So reservoir levels in the state are in good shape. The upper Colorado Basin, of course, has been suffering from a couple decades of really dry conditions. So this is a text that I pulled from the Bureau of Rec site indicating the status at Lake Powell, which last year was only 40% of average volume, and this year is perhaps a little better, and inflows are anticipated with the snowpack that's accumulated to exceed 110% of average, so that when all is said and done, the volume in Lake Powell should be a bit higher, greater than what was experienced last year. So their forecast, middle of the road forecast, is for 55% of capacity compared to 47% last year. Mike Dettinger has put together this nice depiction of snow and reservoir water storage throughout the, in this case, the Sierra Nevada region in the state of California. And we can see here pretty much reinforcing the message that previous slides showed, where snowpack was quite high compared to the normal indicated by the gray shading there. Reservoirs are actually above the longer term averages indicated by the blue envelope there, and consequently, again, the water storage in the state of California this year looks to be in good shape. Just putting the precipitation, in this case in the Sierra into context of a longer period, it's interesting that now we've had 2 of the last 3 years where precipitation was decidedly dry, 2017, and decidedly wet, excuse me, in 2017, 2019. And that's quite a contrast to the dry spell that had developed beginning in about 2012 and proceeding through arguably 2015, although 2015 reached 2015-16 was just about average, but not above. But again, an indication of the great volatility of precipitation from year to year that we experience here in the far west. And we'll see, of course, what happens in years to come. This interesting. This year was a mild El Nino, certainly not a large one, but as indicated by the Niño 3.4 central equatorial Pacific sea surface temperature anomaly aggregate. You can see that this last year was just about a degree Celsius above average in that central equatorial Pacific region, which is known to be a important influence on global atmospheric circulation and climate. The present ocean conditions, surface temperatures are shown in the map here, and showing that there's still warm water that's occupying parts of the tropics, including that central equatorial region. Waters along much of the west coast are warm, and it turns out that in terms of let me go one more slide. The forecast for ENSO conditions, either warmer or cooler tropical conditions that are compiled at the IRI and CPC based on probabilistic estimates, are indicating that El Nino conditions may persist through this next early to midwinter, shown by the amplitude of the Niño, El Nino tendency, reddish bars here in this probabilistic depiction that they show. A set of different model projections is shown on the right-hand side, and with one exception, most of the forecasts are tending to have persisted warm tropics over the next several months. So we'll see what happens. I just wanted to point out that the circulation during the last couple of months has been one where the storm track across the mid-latitudinal North Pacific has essentially had an open gate into the California, perhaps Southern Oregon region, indicated there by the low geopotential heights, negative anomalies, bluish colors on the left-hand chart, a decided high pressure, high geopotential height anomaly sitting over the Gulf of Alaska and on into to Western Canada and Alaska, encouraged storm track to dive farther south. Interestingly, this pattern in the latter part of winter, let's say, or the earlier spring, kind of looks like an El Nino response. But interestingly, the core winter months, which are shown on the right-hand side, December through February, really don't have that that signature of a deepened Aleutian low, but they do have this negative anomaly that sat over California and other parts of the West Coast that resulted in precipitation largely in parts of January and throughout the February period in the West. So the big picture of circulation was kind of a mixed bag, but all told, it was relatively bountiful as far as precipitation here in our region. So with this, I'd like to just shift towards looking into the relatively near future. So this is now a view from CPC showing their 3 months outlooks for temperature on the left, precipitation on the right-hand side. As you'll note, if this materializes, we'll have quite a transition from the relatively mild and even coolish conditions that we've seen in the last few months. And they're indicating that temperatures for the June, July, August period would be relatively warm in California and Nevada, in fact, over much of the West, with then a sort of wave train-like feature with cool in the central part of the CONUS region and warm again on the East Coast. The pattern that they're looking towards has wetness throughout the Rockies and parts of the Intermountain West, brushing up into Nevada, but not very strongly. Equal chances over most of California. So I guess time will tell as far as precipitation here in this June, July, August period, where of course climatologically we don't get very much anyway. But that's the 3 month outlook from CPC. And as far as the shorter range, you can see similar conditions projected for weeks 3 and 4, which take us into the latter part of May through early June, where they're showing warmth developing along the West Coast, including California. And again, equal chances as far as precipitation. Pacific Northwest with persistent dry conditions, wetness throughout some of the regions of the nation that have been experiencing wet conditions, parts of the Missouri basin there, interestingly, looking forward. As I mentioned earlier, I think one of the hallmarks of this last season was the distribution of precipitation, which was relatively wet in the earlier part of winter, and certainly during some of the latter winter and spring months. This is the Northern Sierra and San Joaquin Basin aggregates that have been put together by the Department of Water Resources here in California. And I would just note in the San Joaquin that the November 2018 totals amounted to about 150% of average. January was respectable at 118%. February was really striking at more than 200% of average. And May actually maybe in relative terms the most remarkable of all at greater than 300% of average. Of course, climatologically, precipitation starts to decline in May. So what we see here is the really widespread seasonal precipitation that is fairly unusual in its seasonal distribution. This brings us to the wildfire potential, and I think colleagues are going to probably cover this, but I guess I would note that one of the sort of two-edged swords here is the wetness of the fuels presently, but also the development of annual fuels along the margin of the Pacific coast, which I believe is the reason that the outlooks for significant wildland fire potential start to get more concerning as we transition from the earlier to the latter summer along the West Coast. So with that, I will turn it back over to Amanda, and if there's time, I'm glad to field any questions. Thank you.
Thanks, Dan. I forgot to mention to the audience that if you have any questions, please feel free to type it into the questions box. We're going to move on to presenters now, but we'll be to the next presentation, but we'll be able to do a few questions at the end as well. Bryan, I'm going to pass control over to you and let me know if you have any troubles. Bryan is going to give more detail on the Wildland Fire Potential Outlook, and he's with the National Interagency Fire Center.
All right. Good afternoon, everybody. Can you see my screen?
Not yet. We can hear you, but we can't see your screen.
Okay. At least you can hear me now. Yeah, we're having some serious IT issues over here, but it should hopefully be showing up there in a second. If not, we have a plan B.
Not yet.
Let me know whenever that first.
Would you like me to go ahead and show your slides from here?
Sure, could you? It's probably something with our network still.
Yeah, that's
That'd be great. Thanks, Amanda.
Okay. All right, just let me know when you'd like me to go to the next slide.
Okay, sounds great. Okay, I see the outlooks. I see the slide now. Okay, if you can get to the next slide. Okay, good afternoon, everybody. My name's Bryan Henry. I'm the meteorologist over here at the National Interagency Fire Center. I'm pretty much the acting national program manager for predictive services. Ed Delgado just recently retired at the end of last year, beginning of this year during the furlough. So we can go to the next slide. We'll go ahead and get started. Okay, see on this image, do you have, let me pull something real quick. Okay, what we have on this image is basically a map of the factors influence of Western fire season severity, and basically we tend to think of this saying, much as you all do, as a giant organism. We started back at the previous fall where we're looking at the moisture at the bottom of that circle there, see how the fall moisture was and pre-existing drought conditions were across the West. In this case, we're looking specifically at California. And for all intents and purposes, we had a fairly dry fall in place across large parts of the West, although in Northern California, it did end up getting some decent moisture during the fall months. Dan just spoke about the abundant winter snowpack that you had up there in the Sierra, and then get up to the Siskiyous, and then going up into the Cascades, at least the southern Cascades anyway. And so that's worked very well up in the higher terrain. And then the weather events of the past couple of weeks have also helped out too, as he alluded to. And so that's been a good thing for us as far as that goes in the higher terrain. However, especially given the current period of time where this is the peak green up period where the fine fuels are growing at their maximum rate, the timing of the precip that we've had across California has coincided with that period of time. So we're getting some really exceptional growth of those fine fuels in those lower and middle elevations. And as Dan showed you on that last slide of his, I can see that we've had some areas that are highlighted mid to late summer for those fine fuels, because we're, in all honesty, a little bit concerned about that. A lot of times these fine fuels are a little more patchy and not as continuous. This year it's a pretty continuous growth, and those grasses are pretty tall. So winter was good to us. Spring was good to us, though perhaps a little too good to us in those middle and lower elevations. However, that cool period of time that we were in with those wet, that again has slowed down the melting of that mountain snowpack, as Dan was talking about. And good news in that is that snow is going to come off later than average. That means that the higher terrain elevations up there in the timber will be in play a little bit later than they traditionally are. So we're expecting some below normal potential up in those areas. So now we're starting to see a little bit of a pattern change out there in the middle to long range models. Basically start seeing a little bit more ridging along the coast and into the Pacific Northwest. And we're going to start seeing that with that warm up, those fuels finally starting to dry back out again, especially in your neighbors to the north up there in Oregon and especially Washington State, where we have some a little bit higher concerns. But again, we're getting to that critical June, July period up there at the top of the circle where the temperatures and the precipitation will tell the tale for the upcoming fire season. Good news in that long-range model data is that we're maybe seeing a little decrease in the potential for those super long duration hot, dry ridge events across the West this year, which has become an exception over the recent years as we've gotten accustomed to all those long duration type events that can see above normal seasons. So that's an upside, a plus for us now. Although when we do get stronger events, they could be a little bit more so located along the West Coast. And then, of course, the wild card in there is convection, monsoonal data that we're looking at, pre-monsoonal data. There is some thought out there thinking that the southwestern monsoon may be a little bit delayed and maybe shifted a little bit further to the east. So that'd be good news for California from that standpoint, as far as convection going up into Southern California, into the Southern Sierra. However, there is some of the long-range data that points towards maybe some more systems coming in off the Pacific and from the west than what traditionally happens. But when those storms come from that direction, at least they have a little bit of moisture with them, usually. But nonetheless, they carry lightning as well, so you'll see fire starts from that. And then, of course, everything plays back into what the fuel moistures are during that period of time. So we can go to the next slide. So here's the map of the wildfire seasonality, how things transition across the West, and we find ourselves exiting May, getting into June. You can see activity traditionally picks up in May and continues into June and intensifies, and going into July and August and expands northward and into the Northern Rockies and further into the Great Basin in that midsection of maps there that go from May through August. Of course, this year, as we're all seeing, this is quite the exception. California's been very quiet. Will remain probably quiet for a few more weeks, we would think, before those grasses get dried and cured out. This upcoming little weak ridge scenario could help start that process, but then there's some long-range data suggesting in about 2 to 3 week time frame that there might be another trough coming in from the Pacific, but we'll see how that plays out, see how accurate that data is. But for all intents and purposes, as we go into June, July, we're mostly getting concerned more so about the latter part of June, all of July, and getting into August about those grassy elevations. So next slide. So over the past 90 days, there's a precip map across the CONUS on the left, and on the right is the last 30 days, and beneath it are departures on temperatures. You can see basically, for all intents and purposes, California has been doing increasingly better with their precipitation, especially over the past couple of weeks, which I'll show you on the next slide here in a second. Temperature has been right around average to slightly below average. So that's helping to helping with that overall green up process, helping to stretch it out alongside with the precipitation. So if we can go to the next slide. Next slide has the same layout, basically the last 14 days and the last 7 days. The last 14 days, that was just amazing. I was looking at a map at the end of last week of California, just over the previous week period, and basically the entire state was 800% of normal or greater on their precipitation when that trophy low pattern set up over them. So abundant moisture, definitely abundant moisture in place. So that the soils are in good shape across California, which, like Dan alluded to, is a double-edged sword, as we'll come to find out here in the next month and a half. Looking at the bottom, you can see cooler than average temperatures with that overall trough pattern across the west. And of course, we'll be exiting out of that briefly, but it seems like we might have a deep low that kind of sets up over Southern California and Arizona here in the short term. Go to the next slide. And then, of course, your own products, Drought Monitor and Drought Outlook. Really no surprises there. I just still can't get over the fact that this is probably as free of a map of drought conditions across the CONUS as I've ever seen. I probably won't see one this free of drought. We are seeing in the southeast, however, a little pickup in fire activity over there. Even though it's kind of short-term type conditions over there, we are getting reports of increases in fuel starts here, one near Jacksonville, Florida. Then we got some few reports out of South Carolina and a couple in Georgia as well. All pretty small stuff, but nonetheless, the fuels are responding to those little low-end drought conditions that you see over there. Over the past year and a half or so, I've become a big fan of the drought change maps. It's really good at showing the trends to the fire directors from the agencies in the bottom right there. And it's been great to watch that evolve over the past year as we've transitioned out of drought across most of the continental U.S. But it's been interesting to watch the Pacific Northwest around Puget Sound area, how that drought's persisted and just continues to be firmly rooted in there. And that's our area of concern for this upcoming season. So we get to the next slide. Soil moisture anomalies. I've been using this pretty faithfully for the last 10 years. The way I use it is more so as a precursor to drought. It seems to pick up on things a little bit before the drought starts showing up on the maps. For example, with the Pacific Northwest, get into the Idaho Panhandle, the Washington State area, that's been there probably at least through the winter months and spring. Pretty much almost in a steady state, which is pretty good confirmation of your drought product. So it's looking really good there, really consistent, and it seems to be highlighting things fairly well as far as some of the earlier activity we're experiencing in Western Washington. But down there in California, those soil moisture anomalies that's probably actually a bad thing in the long term, because that's just indicative the soil's got a lot of moisture in it, and those grasses have absolutely everything they need to grow to reach their full potential and then some. So that extends eastward, of course, into the Great Basin, as you can see. And they've got a really good grass crop over there. One little bit of good information coming from them is that the grasses there from the previous two robust grass crop years have been mashed down. They got some snow in the basin over the winter, so we're really only dealing with this year's growth in the Great Basin. Nonetheless, it's still a good crop. Then go to the next slide. Okay, here's some of the fire danger indices that we tend to follow, and also the latest EDI map that's available off the site this morning. And looking at the burning index, that's more so wind driven, but it's picking up on some stuff out there in eastern New Mexico, West Texas area. That's more so due to some winds they're expecting with that low that's dropping south through California, creating a strong southwesterly flow over the eastern part of the Southwest. And so that's a short-term concern. But on the upper right, that's the energy release component, a little better indicator of where you're at in regards to the fire season. You can see it's picking up on some dryness and some receptive fuels there in the southeastern states, but across the west, it's very quiet, almost crickets. I mean, there's nothing going on with that. However, I've become a big fan of EDI, especially as we get into the midsummer. That's good, picking up on those really short-term drought conditions with those fuels with evapotranspiration deficits, and it seems to be continuing to pick up on some of that drought stress, at least in along the Cascade Crest and west, going through Washington and Oregon. So I don't think that's going anywhere anytime soon. It'll be fun to watch that for the next couple months to see how that evolves and how the fire activity evolves alongside of that. It did really, really well the last 2 years down in California, especially last year with those big fires. So a very good performer. All right, so we can have the next screen. All right, now about this time of year, of course, the mountain snowpack maps for us from our standpoint are of little use because most of the snowpack is gone at this point in time. But looking at this current map, it actually tells a pretty good tale to me of how things have progressed through the spring months. As you look in the Cascades, snowpack was below average through the winter months, and going through the spring, the melting of the snowpack up there in Oregon and especially Washington melted off at a faster than average rate. So that's going to probably exacerbate the conditions across there once we get to the peak of the fire season. Maybe northwest Montana might get into it as well, and the Idaho Panhandle too. But along in the south of that, or southeast of that, the snowpack again coming off at a slower than average rate, and things are just coming off very nicely in that higher terrain. So the timber in those above normal areas, we're not as concerned about that this year, at least not till August. So my guess is up there in those higher terrain, they're going to have a compressed but active fire season. Again, it's just the mid and lower elevations. So if we can go to the next slide. Next 7 days worth of precip forecasted by the Weather Prediction Center. Starting to see some trends towards drier type conditions across the West. It's always nice to see precip on the map for the western states, and we still see some across the Great Basin, get into the northern Rockies and maybe Oregon and the Cascades as well. But it's definitely a downward trend that we're starting to see, as we should expect about this time. However, if you look down there along the border country in Arizona, Southern California, those areas have been dry for some time. So do not be surprised to see fire activity picking up there along the southern border. Southeastern states, again, looking fairly dry. Might get a little more precip out there around Cape Hatteras area in North Carolina, but for all intents and purposes, those areas could use a little bit more precip. So I wouldn't be surprised to see some low-end fire activity continuing, at least until the tropical season kicks in and we start seeing a little bit stronger, maybe sea land breeze activity over there with convection. Next slide. Here's the current 8 to 14 day outlook, basically hitting nicely on chances for drier than average conditions and warmer than average conditions as well, at least across the northwestern quarter, and then going up the west coast for those warmer than average conditions. Seems like it might be based off a little bit of older data. This morning data that I was looking at this morning suggested that this would be more of a short-lived type deal, that maybe after that day 14, possibly, you might see a little bit resumption of at least average type temperatures and average type precipitation across the west. But still looks like there's a little bit of a wet bullseye, probably in response to low residual troughiness over Southern California getting into the basin. And for all intents and purposes there, that's somewhat significant in that, given the timing of these maps, this is usually the period where we start experiencing significant drying and curing. And I don't really see anything there that concerns me too much, except for possibly that heat signature going with a possible thermal trough going up through California during this period. Next slide. Okay, so some takeaway thoughts. Again, we got a resumption of warm, dry conditions going up the west coast. So that's something that bears monitoring. Hopefully it's not too long of duration, but if the historical averages pan out, this is the beginning of the summer heat. So we'll see how that plays out going forward. In the southwest, that trough out there to the west over Southern California is helping to keep the heat down. We're not getting strong ridges building over the southwest. That's a good thing. But it is create some abnormally breezy, dry conditions, which kind of offsets that. But at least the humidities aren't down around 4 or 5%, and the temperatures are not 110. So again, kind of balancing things out. Talked to my counterpart down there. He's not too concerned about the southwest this year as well. They do have some heavy grass crop growing up there in the Four Corners, but that has yet to cure out, which is kind of unusual. Usually it's very much in play right now, but again, they were pretty moist. See if we, next slide. Again, this patterns that we've seen thus far and some things we're seeing in long-range model data are suggesting that the southwestern monsoon could be delayed a little bit if we get back into that trophy type pattern over the southwest, or if we get into a zonal flow, that could also help delay the southwest monsoon. Best guess from our climate guys down there in southwest is that monsoon could be about 1 to 2 weeks later than average and a little bit further east on its push. The southeast really is not going to see much relief, we don't think, based on what we've been looking at, although the ridge will flatten and they will get out the intensity that they're getting, I guess, today and tomorrow and previous days as well. So that at least will help them out a little bit. Humidities might be up a little bit, but again, I think they're just going to continue to see a little bit of low end fire activity over there on the southeast. Alaska, I haven't talked about them at all. The climate outlook's been very consistent, very steady, and verified very well. They are projecting and have been projecting above average temperatures, and that's exactly what they've been getting, with above normal precipitation, which is also what they've been getting. So it's not enough precip to shut down their fire season up there, but it is enough to help keep things at bay and from getting out of hand like we've seen in years past. So we're expecting a very gradual, maybe average to low end of average type year up in Alaska, followed by an exit out of their fire season come July. The next slide. And then here's our fire season outlook maps. Again, since May's pretty much over with, I'll just skip over to the June map in the upper right. Basically, you see that little dichotomy there in California. The green that you see on the map for California is indicative of the higher terrain, what we were talking about with them coming into play much later than average and maybe not being as intense. And then the reds are for those grassy elevations surrounding the Central Valley. July map, same thing. August, probably normal activity in August up in the higher terrain and continued above normal potential down there in the grasslands, and potentially some very significant fire activity up there as well, in those elevations as well. And I believe that might be my last slide. Oh yeah, there is one more. That's just a summary of that, basically what we've been talking about. But I'd be happy to entertain any questions. I need to jump on another conference call here in a second.
Thanks, Bryan. I don't see any questions yet, but we can follow up with you afterwards since you do need to hop off here. Sure. Thanks for that great presentation. And then we do have one more talk scheduled. I apologize, folks, we're running a little long this time. But we have one more talk. I hope you'll stick around. Dan McEvoy from the Western Regional Climate Center is now going to present on a project where he's been looking into drought indices and wildfire in California, Nevada, as part of a NIDIS-funded SARP project through NOAA. And Dan, if you want to go ahead and take a chance, or not take a chance to present.
All right, thanks a lot, Amanda, for the introduction. Are you seeing my full screen there?
Yeah.
Okay, great. Yeah, so thanks everyone that is able to stick around. I know we're going over time a bit, and I'm going to try to make this a bit abbreviated from what I had originally. But I just want to summarize a project we've been working on the past few years, looking at some of the things we heard about from Bryan as well, relationships between drought indices and what that might mean for wildfire potential, specifically in California and Nevada. And I don't need to summarize what the DEWS are. Amanda did a good job of that in the introduction, but this project was focused on California and Nevada DEWS. And it was a NOAA and NIDIS SARP sectoral applications research program funded project. And so there were two main goals. One was to quantitatively kind of evaluate how drought indices relate to specifically to dead fuel moisture, things like the 100 and the 1,000 hour fuel moistures. And then there was a second part that was much more involving stakeholders and actually kind of trying to integrate some of this information into the wildland fire management. And so I just want to real quickly summarize this graphic on the left, which is kind of one of the key graphics from our paper in climate that just got published. And so what this was showing really, we looked at 4 different drought indices. EDI was one of them that Bryan had already mentioned. That's the Evaporative Demand Drought Index, and only considers evaporative demand. The SPEI is similar, but that looks at the difference between precipitation and evaporative demand. And then the SPI is only precipitation. And those 3 indices all have the ability to look at different time scales, from shorter time scales, say a month or so, even down to a couple of week time scale, all the way out to time scales of what the drought conditions have been like over the past year or even longer. And then the final one is the PDSI, the Palmer Drought Severity Index, which has been in circulation and been used for decades now. And so we looked at seasonal fuel moistures. And so this top panel is looking at the correlations between the seasonally average June, July, August 1,000-hour fuel moistures compared to these drought indices at different time scales and lag time. So this is at the end of May. So this would give some sense of the predictive capacity of these different drought indices for summer 1,000-hour fuel moisture. And that's the 3 to 8 inch diameter fuels, a measure of how dry those dead fuels are. And so there were 2 kind of main take-home points from this analysis. The first one was that the indices that included evaporative demand, which are EDI and SPEI, PDSI does too, but a bit differently. So if they include evaporative demand, and also if they have the multi-timescale option, those are the two indices that correlated the best to fuel moisture. And those 2 were EDI and the SPEI, and we saw these boundaries up here are the predictive service areas used by management in the western states. And so we saw very strong relationships between EDI and SPEI. EDI kind of did the best in California, and SPEI did a little bit better in Nevada, but they both did quite well for summer. And there were some decent relationships in spring as well. And so I briefly want to I'm going to talk a bit about what we did with EDI now, and kind of how it was tested this summer in California, and some case studies. And so the EDI and the SPEI both contain that evaporative demand component. This is the often called the potential ET, or the amount of water that could be transpired and evaporated into the atmosphere given an unlimited water supply. And so we use a reference ET for EDI, and this is a physical model. It uses temperature, wind, humidity, and solar radiation. And so all these drivers, they're really linked to kind of drought development and dynamics, and also fire weather, especially the humidity and the wind speed and temperature. But it's important to understand, for the sake of fire and drought, that the evaporative demand that we're using is not the same as the actual evapotranspiration. So it doesn't tell you anything about the land surface itself. That's the actual ET. This is the evaporative demand, and it's purely driven by the near surface weather conditions. So real quickly, this is we saw this, I think, the same map from Bryan in the last talk. We have the 1 month EDI, which basically tells you the departure from average evaporative demand over the previous month time period, where the reds are above average, which would be hot, dry, windy, less clouds, and blues would be cooler, more moisture, less wind, and kind of below normal evaporative demand. And really the 2 places that stand out on the 1 month map here are, again, the Pacific Northwest, specifically Washington and Oregon coast, and then also the Southeast. We have a website available, which I'll mention again in a few slides, but this is the main website. And we also have another site where you can get these regional maps. So this is just zoomed in for the same period, but you can see the highest drought categories, the top 2 percentile, or those darkest red categories, showing up in Western Washington right now. And also, so what we mapped here are not the actual EDI categories, but the percentiles, which we chose to use that to help with things like the U.S. Drought Monitor, where they convert these things to percentiles anyway to be consistent with all the different indices. So that's the way we chose to do our mapping of EDI. And I mentioned before that the different drivers are important, and if you can avoid using just a temperature-based PET, it's strongly encouraged to use a physically based model, and that was shown really well by some work that Mike Hobbins has done. He basically decomposed the 4 drivers of temperature, humidity, wind, and solar across the country for each month, showing which driver contributes the most to the total evaporative demand values and anomalies that we would see in eddy. And so some really interesting things came out of this study from Mike. And if we focus kind of on the summer into the early fall in the Southwest and over large parts of the West, there's these big areas of red, which indicates that wind speed is the most important driver for controlling that evaporative demand, and it's not just temperature. And in the Southeast in the summer, where you typically have a lot of humidity and cloud cover, the solar radiation is actually the strongest driver. And then other places in the central U.S., it is actually temperature. So it's really important when you're using things like eddy and SPEI with these physically based evaporative demands to kind of think about what that means in context to the seasonality and the dominant drivers. As part of this project and the paper, we did a case study on the Tubbs fire, which actually occurred in 2017, which was part of a much bigger North Bay wildfire outbreak in October of 2017. And this is just showing the 2-week eddy. I believe this was the day before the fire started. So we have these highest categories, very high evaporative demand in the 2 weeks leading up to the start of that fire. And so the next couple slides, I'm going to show the breakdown of the evaporative demand time series, but then also the contributions from each of those 4 drivers to kind of see which was contributing the most to these anomalies. And so this is a 2-week moving average time scale of the evaporative demand for Sonoma County. Anything above this horizontal black line is above average, above normal. And so we can see that the entire period, and then the vertical line there is the start of the Tubbs fire on October 8th. So this entire period, we had very high evaporative demand above normal. The dotted line actually shows the percentiles for a climatological context. And we were, on these two spikes, we were above the 90th percentile, approaching 95th or 98th percentile leading up to the fire. And so now when you overlay the drivers, so each one of these colored lines is the contribution from that driver to the anomaly. And so the red is temperature, the blue is humidity, the green is wind speed, and then the purple is the solar radiation contribution. And the early spike in late August, early September was strongly driven by temperature. This was a heat wave driven evaporative demand anomaly where the other drivers were actually contributing negatively. So that would be below normal humidity and wind speed. But then we saw this big shift where the temperature contribution dropped to almost nothing, and the humidity contribution really cranked up and became the dominant driver leading up to that fire. And so that kind of signals a shift in the larger scale kind of weather pattern where we saw this really dry air mass in place that was one of the contributors to the fire potential. This was not necessarily contributing to the spread of the wildfire, which was largely driven by the strong wind event. But this shows another example of how to use eddy and the evaporative demand as a fire potential indicator leading up to these large fires. And finally, I wanted to mention some of the stakeholder engagement. We did a couple of webinars after we completed all this analysis with stakeholders from predictive services, Forest Service, the National Weather Service, and some other agencies to kind of tell them about what we found and also point them to where they can actually find these tools. Hopefully our goal was to get some feedback from them throughout the fire season last year. And we wound up with one primary tester, and that was Brent Wachter from North Ops or Northern California Predictive Services. And Brent gave us some great feedback and some things. He actually showed us some applications that he used. And so the graphic here is showing what eddy looked like actually. On the top was the 1 in 6 month eddy on the day that the campfire started on November 8th, and then the bottom left is the day that the car fire started in late July. And so we see these very strong signals of high evaporative demand and fire potential from Eddy. And so a few things that Brent did with Eddy was he used them to brief CAL FIRE, showing them these short-term eddies were really popping and showed fire potential. He replaced the U.S. Drought Monitor with Eddy maps for these Region 5 severity funding requests, and I have more on that on the next slide. Seasonal outlooks, and they're really working to get Eddy into the fire behavior field reference guide and the curriculum to kind of educate the fire managers and firefighters on some new drought information. And I mentioned replacing the drought monitor. So in their severity funding requests, and so for a while they were just looking at the drought monitor as their main drought signal. And this isn't saying that the drought monitor isn't a good product, but it was never designed for this short-term fire behavior or fire potential in California, because that's typically the dry season anyway. And so you see these two maps from late July where the drought monitor does show some D1 in the car fire area, but the two-month Eddy was showing this much more highlighted area of kind of above the 95th percentile categories. This is indicative of more rapid changes in the fuel moistures there and higher fire potential. I already showed where we can find Eddy here. Another tool is Climate Engine, where you can get Eddy, other drought indices, and satellite data. So I encourage people to check that out as well. And just wrap up with mentioning that we're hoping to get more testing from other folks outside of California, around the West and other parts of the U.S. during this fire season. We do have some Eddy forecast products that are in development that we're working to improve, and then also on the global application of the Eddy, which we do have available on Climate Engine right now, but there's quite a bit of lag time on that, and so we're working on improving that product for global fire potential monitoring. And just a shameless plug for our paper is available online that goes into the nitty-gritty of a lot more details than what I just covered, and all our co-authors there I wanted to acknowledge as well. And that was all I had. This was from late March in the Sierra, and so this is going to lead to all this snow to a delayed start, as Bryan mentioned, to the fire season, at least in the higher elevations. So that was all I had, and thanks for everyone who was able to stick around for that.
Great, thanks, Dan. As I said, thanks everyone who has stayed through the whole presentations, and Dan, thanks to you and to the other Dan and Bryan for great presentations. At this time, if you do have some questions, we can take them in here, or for sake of time, we might follow up with you afterwards. If you have questions, send them to me or to one of our speakers. Just a reminder that the recording of this webinar will be available on drought.gov and our YouTube channel relatively soon, as well as the two-pager summary for the webinar as well. Other than that, I'll see if there's any quick questions, and otherwise we'll go ahead and close. Let's see. Dan, there was a quick question. It was for Bryan, but since Bryan had to leave, is how far out can we forecast wind direction strength as a potential to spread fire? He thought maybe you could answer it since we did lose Bryan.
Yeah, of course, wind is one of the most difficult things to accurately forecast, especially at finer scales. But in terms of actual forecasts for fire spread and fire behavior, I don't think there's too much confidence in those wind forecasts out past a few days. And I know the fire managers do use those really high resolution models of wind to look at the next 1 to kind of 3 days when they're kind of assessing fire behavior and that kind of danger once a fire has already started.
Great. That's the only question I saw, and so I guess for the sake of time, we'll go ahead and close. Our next webinar will be in July, back on a regular Monday schedule. Today, obviously, we moved it for the holiday, so thank you everyone for listening in, and thank you to our presenters. Hope everyone has a great week.